In this video, we will be assembling an Atlas kit. If you do not have a kit but want to get one, you can find a link to purchase it below this video, along with a link to the written guide to follow along with. Along with the components included in your Atlas kit, you will also need a few tools: a soldering iron and solder, a solder sucker, wire cutters, and optionally some poster putty. The putty is used for holding components in place while soldering, but there are plenty of other ways of doing that. Find the 1 kilo-ohm resistor and bend the metal leads so that they fit in the designated holes on the back of the PCB. The orientation of resistors does not matter. Hold the resistor in place. I'm using poster putty here. Then solder the resistor onto the board. Once soldered in place, use your wire cutters to clip the excess metal leads on the resistor. Repeat this process for the 3 220 ohm resistors. On the other side of the PCB, solder the last resistor, the 10 kilo-ohm resistor, in the designated spot. Next, we will solder the diode. Unlike the resistors, the orientation of the diode matters. Match the banded side of the diode with the side of the diode symbol on the PCB with the white band, then solder it into place. Next, we will solder the LEDs. The orientation of the LEDs also matters. When inserting the LEDs into their designated spots, make sure that the shorter lead is toward the outside of the PCB. In order from top to bottom, solder in place the red, green, and blue LEDs. Next, solder the transistor. Make sure to align the flat side of it with the flat side of the symbol on the PCB. The leads on this component are very close together, so be extra cautious with how much solder you use. And double check the pins after soldering to make sure that they aren't connected. If you accidentally put too much solder on, use the solder sucker to fix it. Next, solder the buzzer. Make sure that the plus marked on the buzzer is on the same side as the plus on the symbol marked on the PCB. Next, solder the IC socket into place. Next, we will be soldering just one of the Node MCU headers, the one closer to the bottom of the PCB near the buttons. The easiest way to do this is to take your Node MCU and place both of the headers on each row of pins. Then place the Node MCU with the headers on the back side of the PCB and hold it into place with putty. This will keep the headers aligned straight. Then only solder the bottom header into place. We only do the bottom header here because soldering the top header will make it difficult to solder some of the other components. Place all of the buttons onto the PCB in their designated spot. They will stay in place by themselves if you press them into place due to the shape of their metal leads. Then solder them in place. Place both of the 7-segment displays into their designated spot on the PCB. Make sure that the decimal point is towards the bottom of the board. Then flip the board over and solder all of the pins into place. Be very careful to not touch the plastic header with the hot soldering iron when doing this. Now place the Node MCU with the top header still pressed onto the top pins onto the PCB, pressing the other row of pins into the already soldered bottom header. Then solder the top header on, being careful to not touch the soldering iron to the 7-segment displays. Now remove your MAX 7219 IC from the foam. This component does not need to be soldered. Instead, it will be pressed into the socket. If you line it up with the socket, you will notice that the pins are bent slightly outward, too wide for the socket. We will need to bend them straighter so that they fit into the socket. I found that the best way to do this is to find a flat surface and very gently press each row of pins back straight, alternating sides of the chip until they are both straight enough to fit. Once they are aligned with the slots in the socket, you can press the IC in, making sure that the divot that is on one end of the IC is pointing towards the buttons. This will require a bit of pressure, so before you start pushing the IC down, be 100% positive that the pins are lined up with the slots in the socket. After this step, you'll have a completely assembled Atlas kit and will be ready to start programming it.